Hello, welcome. A to the power of 3 minus b to the power of 3 equal to 61. Before we go ahead with solving, we have a condition. And our condition is that a comma b is greater than 0. Now, let us proceed further. Solution. We have a to the power of 3 minus b to the power of 3 equal to 61. The key to solving this algebraic question is to try to re-express this left-hand side, which is a to the power of 3 minus b to the power of 3. We can rewrite a to the power of 3 minus b to the power of 3 as a minus b times a to the power of 2 plus ab plus b to the power of 2 equal to 61. The second step we are going to take is to rewrite 61. 61 can be written as 1 times 61, or we write 61 as 61 times 1 as product of primes. Let's call this first line case 1, and let's call this second line case 2. But we are going to consider only case 1. Reason being that from this our condition, a comma b greater than 0, that means that a minus b will always less than this guy, a to the power of 2 plus ab plus b squared. So let's proceed further. So for case 1, don't forget we are going to ignore this. From here we're going to have a minus b times a to the power of 2 plus ab plus b to the power of 2 equal to, we will now replace this 61 with this guy, 1 times 61. This implies that a minus b is equals to 1. Also, this guy goes to this, a to the power of 2 plus ab plus b to the power of 2 is equals to 61. Let's call this equation 1 and let us call this equation 2. From equation 1, this guy, a minus b equal to 1. When b goes to the right, it becomes a equals to 1 plus b. So let's call this the third equation, equation 3. We will now substitute this equation 3 into equation 2. So sub equation 3 into equation 2. That means anywhere we see a, we will replace it with 1 plus b. So from here, we're going to have 1 plus b all square plus a times b, that is 1 plus b times b plus b to the power of 2 equals to 61. If you expand this guy very well, 1 plus b all square, you will get 1 plus 2b plus b to the power of 2 plus b times 1, that is b, plus b times b, that is b square, plus b square equals to 61. Now let us add the common terms. B square plus b square plus b square, that is 3b square, plus 2b plus b, that is 3b, plus 1 equal to 61. 3b square plus 3b plus 1. When this guy comes to the left, it becomes minus 61 equal to 0. So we have 3b square plus 3b. 1 minus 61, that is minus 60 equal to 0. You will observe that we can factor out 3 from these guys. Doing that, we're going to have 3 into b to the power of 2 plus b minus 20 equal to 0. Let's divide both sides by 3. We have 3 into b squared plus b minus 20 all over 3 equals to 0 over 3. Clearly, this cancels this. So we are left with b to the power of 2 plus b minus 20 equal to 0 over 3, that is 0. You will observe that this quadratic equation is factorizable. We have b to the power of 2 plus, we can write b as 5b minus 4b minus 20 equal to 0. B is the common terms here. If we factor it out, we're going to have b into b plus 5. We can also pull out minus 4 from this guy. Doing that, we're going to have minus 4 into b plus 5 equal to 0, because minus 4 times b gives minus 4b, Minus 4 times 5 gives minus 20. So let's proceed further. This implies that b plus 5 times b minus 4 is equals to 0, which also implies that b plus 5 is equals to 0 or b minus 4 is equals to 0. Clearly from here, b is equals to negative 5 or b is equals to 4. Notice that we have two values for b here, but we have to ignore the one that is less than 0. You will observe that this guy is less than 0. Reason why we ignore this is that since a comma b is greater than 0 and this value of b is less than 0, so we are going to ignore this guy. So the value of b is equals to 4. We can now use this value of b to obtain the value of a. So let's proceed further. So since a is equals to 1 plus b, this guy comes from the third equation. Let me show you. This guy. So let's proceed further. So a is equals to 1 plus, what is b? This is b, 4. A is equals to 1 plus 4 is simply 5. Therefore, the value of a is equals to 5 and the value of b is equals to 4. We can verify that, so let's do it. The original question says a to the power of 3 minus b to the power of 3 equals to 61. The value of a that we obtain is 5 and the value of b is 4. So from here, we're going to have, what is a? A is 5. We have 5 to the power of 3 minus, what is b? B is 4. 4 to the power of 3 equal to 5 to the power of 3 is simply 125 minus 4 to the power of 3 is 64. This is equal to 125 minus 64 is 61, which is exactly what we have on this right hand side. That indicates that, therefore, a is equals to 5 and b is equals to 4. This is the required solution. That's it. Thanks for watching.